Alright, hey guys, in this video we're going to start talking about annuities. Annuities, an annuity is just a sequence of equal payments that are made at equal time periods. So for an example, in a retirement account, like an IRA, that's an example of an annuity. Okay, so at a certain point you make a certain deposit into this account, for a certain amount of years, and during this time it's gaining interest. And so at the end of, whatever the time frame is, you have the money that you put in plus the interest that was drawn off of that. And so for this problem, what it's asking is saying, okay, we're going to put in $4,000 at the end of each year. The rate is going to be 4% compounded annually for 30 years. And so Part A is asking us to find, okay, at the end of those 30 years, how much money is in that account? How much money have we put in, plus how much interest has been drawn off of that? And then in Part B says how much interest was earned off of that amount. So let's find Part A first. So we're just going to plug in. So A equals my P, which in this case is 4,000, and then times 1 plus the rate, which is 0.04, raised to the T, which is 30, minus 1, all that divided by your rate, which again is 0.04. Alright, so now if we just start trying to solve this out a little bit, you want to make sure that you do not round until you get to the final answer. Okay, so you might have to put this in your calculator and kind of solve it as a whole first, and that's what I'm going to do. And I'm going to explain to you the steps that I'm taking in order to solve this. So what I'm going to do first, I'm going to take my calculator and I'm going to do 1 plus 0.04, and that's going to give me 1.04. Now I'm going to raise that to the 30th power. When I do that, I get 3.24339751. I don't want to round there. I'm just going to immediately minus 1 from that, and that's going to give me 2.24339751. And then that takes care of everything inside that bracket. Now we take that value and multiply it by the 4,000, and that gives 8,973.59004. Okay, so I'll write that out. So on the top, when you do all the calculations for the top, you get 8,973.59004, and on the bottom we have that divided by 0.04. And so now if we do that calculation, what we get is, and here I am going to round to the nearest cent. Okay, so I get $224,339.75. Okay, so at the end of this 30 years, if we put in $4,000 at the end of each year, plus the interest, we'll have a total of $224,339.75. So that's Part A. Okay, so this is Part A. So now Part B is saying, okay, well, how much interest did you draw? Well, to find that, we got to figure out how much money we put into the account. Well, if I put $4,000, okay, if we put $4,000 for every year for 30 years, then we multiply that by the 30. Okay, and what this is going to do, this is going to tell me how much money I put in the account myself. So 4,000 times 30 is $120,000. So that's how much money that I put into the account. So then to find the interest, okay, so for Part B, to find the interest, you do your accumulated total, okay, for over the 30 years, and we subtract the amount that we put in. Okay, so you take that accumulated total, that $224,339.75, and then you're going to minus the $120,000 that we put in ourselves. And what that comes out to be is $104,339.75. And what that is the amount of interest that we drew off of the account. Alright, here we have another annuity problem, but this time we're putting in $70 at the end of each month, and it's going to be compounded at 6% monthly for 20 years. And so again, we want to find the value of the annuity after the 20 years, and we want to then turn around and find the interest. Okay? So, let's just plug in for what we have. Alright, so let's just plug into the formula. So A equals your P, you're putting in $70. You got to be really careful, make sure you use the brackets and the parentheses appropriately here. Your R is 0.06. Your N is the number of times it's being compounded monthly, so that's 12. And then N to the T, N times T. So again, that's 12 times your 20 years. Okay, so your N is 12, your T is 20. And then minus 1, close your bracket, and then divided by R over N, which is 0.06, again, over 12. Okay? So a lot going on in this, and so you've got to be really careful. Alright, so let's clean it up a little bit. So again, we have 70. Now, you know, you got to be careful how you punch this in. I would do 0.06 divided by 12, and then take that value, add it to 1. Okay? Now, 12 times 20 is 240. Okay? So you know, it's up to you how you feel comfortable plugging this in. But I would do, you know, just do it all once, kind of in your calculator, so you're not having to round anywhere, and you make sure you get the right answer. So the inside part, the parentheses, is 1.005. Then we raise that to the 240th power, okay? And then we're going to minus 1 from that. And so what we get is 70 times this long decimal, 2.31. Alright, so that was 2.3104476. And now on the bottom, if we do that 0.06 divided by 12, that comes out to be 0.005. Okay, so now I'm going to take all this, and I'm just going to calculate everything now. I'm going to do the 2.3102. Make sure you use all the decimals. So 0.204476 times the 70, and then divide that by the 0.005. Okay, when we do that, we get our A equals $32,342.86. Okay, so that's how much money we will have accumulated in our account if we put in $70 at the end of each month for 20 years. All right, so that's part A. Now part B asked me to find the interest amount. So what we have to do is we got to figure out how much money did we pay into the account. Okay. So I'm just going to kind of separate this off. So now we paid $70 for every month. So that's 70 times 12. We did that for 20 years. So then times 20. Okay, so we did $70 for 12 months for 20 years. So you have to do 70 times 12 times 20. And that's going to give you a total of $16,800. That's how much money we put into the account ourselves. So then to find the interest, okay, so now to find the interest, we take the $32,342.86, and we subtract the $16,800 that we put in ourselves. Okay, so you got to make sure you subtract the accumulated amount from the interest amount, and when we do that, we get a total $15,542.86, and that is how much money we gained just off of the interest.